Hello, my name is Emily, and today I'm going to be talking about shooting a basketball and how projectile motion plays a role in it. First, I will start by talking about the background of basketball. Basketball was created in Springfield, Massachusetts by Dr. James Naismith in 1891. He was told by his mentor, Luther Halsey Gulick, to create an activity to keep the YMCA athletes active during the harsh winter months. When he originally designed it, he had it as a 9-on-9 type of game, which has since been updated to a 5-on-5 game, and more recently 3-on-3 has been gaining popularity. It was first included as a demonstration sport in the 1904 St. Louis Olympic Games, where it made its official debut in the 1936 Berlin Olympics. Women's basketball was added to the Olympics in Montreal in 1976, and most recently 3-on-3 basketball was added in the 2020 Tokyo Games. The ultimate goal of basketball is to shoot the ball into the hoop. By the end of the game, you want to have made more baskets than your opponent. Now, what exactly is a shot? A shot is, and the simplest way to put it is that a shot is an overhand throw. There are many types of shots. Two of the more common ones are jump shot and lay-in. There's also shots like the hook shot. A jump shot is most commonly used when shooting distance. A lay-in is usually used when shooting really close to the hoop. And a hook shot is when you're not facing the basket, but you're close to it. So you have to hook the ball over your head and into the basket. Now that we know more about basketball, let's talk about projectile motion. Projectile motion is the motion of an object that is thrown into the air, subject to only the acceleration of gravity. Since gravity is vertical, both accelerations are constant, so we can use simple equations to calculate projectile motion. To find projectile motion, you need the initial launch angle, initial velocity, the time of the flight, acceleration, horizontal velocity, vertical velocity, displacement, and maximum height of the object. Projectile motion equations. The equations that are most commonly used when talking about projectile motions are the final velocity equals initial velocity times acceleration in the time of flight. Final velocity squared equals the initial velocity squared plus 2 times the acceleration and displacement. And the third is displacement equals initial velocity times the time of the flight plus 0.5 acceleration in times squared and the time of the flight squared. Now let's move on to some research articles. In the article Projectile Motion in Real Life Situations, Kinematics of Basketball Shooting, the researchers looked at the optimal angle when shooting a basketball. They found that the optimal angle of the shot really depends on the height at which the ball is released. The higher the release point, the smaller the angle should be. They compared it to the typical 45-degree angle that is most commonly used when using projectile motion. Whether the ball is higher in the air or the athlete is taller, it should be a smaller angle than if the athlete is shorter or holds the ball lower down. Another research article called Analyzing the Optimal Angle in Basketball Free Throws. They looked at 30 NBA players' data to determine the player's height and decide what the optimal angle for each player would look like. They found that the 45-degree angle that most commonly is told by researchers that is correct was actually not right. They found that the optimal angle depends on the player's height, like the last researchers found, and that the taller the player, the lower the optimal angle would be. So if you're over 6 feet tall, you would hold it higher than someone who is 5'2". So the person who's 6 feet tall would need a shorter and smaller release angle than the player who's 5'2". In another research article, the effects of increased shooting distance in basketball jump shots, they looked at the different aspects of projectile motion in relation to shooting a basketball instead of just focusing on release angle. They found that the ball's release speed increases with shooting distance. They found that there was no trend with the release speed and shooting distance with the angle itself. So it doesn't matter how far away you are from the actual basket, the release angle will stay the same. It also doesn't matter how quickly you shoot, your release angle will still be the same. All subjects released the ball while in the air, meaning they would have a smaller release angle than if they just stayed on the ground, and they increased elbow extension, angular velocity, and the center of mass. In conclusion, two of the articles have similar findings. They both found that the typical optimal angle of 45 degrees is not always right. The true optimal angle depends on the height of the player shooting the ball and how high they hold the ball and whether or not they jump when shooting. The third article looked at how speed would change the projectile motion. They found that speed did not affect projectile motion or the release angle of the shot. And these are my references. And references continued.